today we're going to look at the method of common bases, and this is a technique that you can use to solve some exponential equations. Okay, so if we start with A, 2 to the x power equals 16. Okay, so you might say, well, it's 4. 2 to the 4th power is 16, so x is 4, and you're correct. However, I want you to think about it coming from a little bit different direction. So 2 to the x equals, can you rewrite 16 as a power of 2? Okay, so 16, so 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th power is also 16. So it's just another way to write 16. So if I look at this statement, 2 to the x equals 2 to the 4th. Well, what must be true of x? Well, x must be equal to 4. Okay. All right, so that's the kind of technique that we're looking at today is, can you rewrite values using a different base? So b, 3 to the x equals 27. So can you rewrite 27 as a power of 3? So 3 cubed would be 27. Therefore, x must be equal to 3. Okay, C, this one's a little tougher. So 5 to the x equals 1/25. So can you rewrite 1/25 as a power of 5? Okay, well, you might start with saying, okay, so 5 squared is 25. So I could do 1 over 5 squared. Okay, so if you want to do the reciprocal, and you're dealing with exponents, to do the reciprocal, then you do a negative exponent. Okay, so 5 to the x would also be equal to 5 to the negative second. Therefore, x must be equal to negative 2. Okay, D, 16 to the x equals 4. So can you rewrite 4 as a power of 16? Okay, so you might kind of think, well, that's backwards. I can do 16 is 4 squared. Okay, but can you rewrite 4 as a power of 16? So let me give you this as a hint. Okay, so you would agree that the square root of 16 is also equal to 4. Okay, so that would be a true statement. Okay, so a little while ago, we were using rational exponents, and you could rewrite the square root of 16 as 16 to the 1/2 power. So remember, 1/2 power would be a square root, 1/3 power would be a cube root, and so on. Okay, so now we've managed to rewrite this so that they both have a base of 16, and therefore x must be equal to 1/2. Okay, so now we're going to review an exponential rule. So 2 cubed to the x. All right, so this is a power to a power. So power to a power, if you remember, what do you do with your exponents? You multiply them. So this would be 2 to the 3 times x power. Okay, now you might say, well, if I simplify that, 2 cubed is 8, and then 8 to the x. So you're right. Okay, that is an equivalent statement. But what I want to focus on with this lesson is that concept of a power to a power. Okay, so b, 3 squared to the 4x power. So again, power to a power. You can take 3, and then you're going to do 2 times 4x, or this would be 3 to the 8x power. Okay, C, 5 to the negative first to the 3x minus 7 power. So you're going to multiply power to a power, multiply your exponents, and this would turn in 5 to the negative 3x plus 7 power. Okay, then D, same thing, power to a power. You're going to multiply your exponents. So this becomes 4 to the negative 3 plus 3x squared as your exponent. All right, so now we're going to kind of combine these two last ideas that we've looked at and use them to solve some exponential equations. All right, so we are going to solve by finding a common base. the first one, 8 to the x equals 32. All right, well, what base can both of those be rewritten as? Okay, so if you think 8 is 2 cubed. Okay, so we could go 2 cubed to the x. Now, can you rewrite 32 with a base of 2? And you can. 32 would be 2 to the 5th power. Okay, so using our power to a power rule, this would be 2 to the 3x power equals 2 to the 5th power. So this is a true statement. Then these exponents must be equal to each other. So 3x equals 5. X is 5/3. All right, B. Same thing. We have a 9 and a 27. So those can both be rewritten as using a base of 3. So 9 is 3 squared, and then that would be to the 2x plus 1 power. And 27 is 3 cubed. So now, using my power to a power, this is going to be 3 to the 2 times 2x plus 1 power equals 3 cubed. So this exponent must be equal to this exponent. I'm going to go ahead and distribute. So that's going to turn into 4x plus 2 equals 3. So go to solve this one. Get 4x equals 1. So x would be 1/4. Okay, one thing I didn't mention was on these equations, you can always take your solution, go back to the original, plug it in, simplify, and then you can double check that you are correct. All right, C, 125 and then 125th. Well, those can both be rewritten as powers of 5. 125 is 5 cubed to the x power. And then we did this one a little earlier. So if you remember, this was 5 to the negative 2nd power. And then that would be to the 4 minus x power. All right, so this would be 5 to the 3x equals 5 to the negative 2 times 4 minus x. So again, I'm going to put my exponents equal to each other. So 3x equals, I'm going to go ahead and distribute negative 8 plus 2x. So I'm going to move my 2x. And x equals negative 8. Okay, one last example for today. Which of the following represents the solution set to this equation? Okay, well, this first piece is written as a power of 2. So can you rewrite 64 as a power of 2? And you can. If you remember back up here to A, 2 to the 5th was 32. So if I multiply that by 1 more 2, that'll be 64. So 64 is 2 to the 6th power. Okay, we have the same bases, so I can put my exponents equal to each other. Now this time, notice that we got a quadratic to solve here. So this one is going to go pretty easy. Since the x squared is our only term with a variable, that means I can use square roots to solve. So x squared would equal 9. I can square root both sides. X is plus and minus 3. So that's your first option here. Okay, now another option with this one, somebody brought it up in class yesterday. When they saw this, they said, let's factor it. Okay, it's a quadratic. We can factor quadratics. And you can. So if you move the 6 over here, you get x squared minus 9 equals 0. Because remember, if you're going to factor, you need to be equal to 0. And then this is a difference of squares pattern. So you're going to have an x plus 3 and an x minus 3. Set them equal to 0, solve, and you get the same thing. Okay, so whichever way you choose to solve is fine. Factoring on this side, and this side we used square roots.